Hello, my name is Blaise Page, and today I will be walking you through my final project for the Spring 2019 Sabermetrics course taught at CU Boulder. So for this project, I generated two new MLB baseball statistics and put them into an interactive web app that other people can interact with. So the two statistics that I came up with are late game slugging percentage, which I call LGS for short, and early game slugging percentage, which I call EGS for short. Now, LGS and EGS both use the normal standard like slugging percentage equation, but the data is basically bisected into two different categories, late game scenarios and early game scenarios. Um, I define late game scenarios as any, you know, at bat that occurs in the eighth and ninth or beyond innings, and early game scenarios are the scenarios prior to inning 8. So I found this statistic to be interesting because you kind of get a little predictive insight onto how well a batter will bat or how much batting productivity he'll get at the plate in early game scenarios versus late game scenarios. So one use of this is trying to predict if current batters or upcoming batters in a batting lineup are going to be more successful in late game if it's coming down to it, or if you need to like put in a relief pitcher, what sort of relief pitcher or starter are you gonna put in to finish out the game with these batters coming up to the plate. So for this project, I used the StatCast dataset, and my code is here in my GitHub repo, and you can clone that and check it out if you want. So with StatCast, since StatCast wasn't, or the StatCast technology wasn't installed in each stadium prior to 2015, I chose to only include players that played in the 2016, 2017, and 2018 seasons. I thought this might eliminate a little bit of bias towards the teams that did or did not have the StatCast technology installed in their stadiums prior to the state range. So there was a couple things I had to do preemptively for this project. One was I did not want to calculate these statistics in real time on my web app. So I basically had to generate a data set that had EGS, LGS, and basically a gain factor for how much a player's batting productivity increases as they get to the plate in late innings versus early innings. So first, I created a massive list of all the players that I wanted to look up. I then used the PyBaseball function player ID lookup to figure out what their MLBAM ID is. Now, MLBAM is a unique identifier for players, and this is actually what StatCast lists as a primary identifier for different batters as the game goes on. So I first had to generate a massive dictionary that maps player names to this MLBAM ID. I then used that MLBAM ID and iterated through the StatCast data to generate a dictionary, or at first it was a dictionary of, the number of at-bats in late and early game scenarios, the number of home runs, triples, doubles, and singles in late game and early game scenarios. And then I stored that dictionary in a pandas data frame and stored it to a CSV file. So once I had that CSV file created, I was able to directly read it in my Flask app, which was the micro framework that I was using for this application. And with that, I was able to create a couple different views and visualizations of how a player's EGS and LGS compare for any given player. Now, my site actually looks better. The styling and the HTML looks better when ran locally. When I deployed the site, the styling got a little messed up. So I'm going to show you real quick how to run this locally. First thing I should mention is that I have quite a few packages installed in my virtual environment here. These are the packages that I use to run my web app. And if you're going to try to run it locally, I suggest, setting up a virtual environment and then also installing these packages. Most of them are already pre-installed with Python 3, but you definitely have to install pandas, NumPy, Flask, and Bokeh, which is the API that I use for generating JavaScript packages that show visualizations. So without further ado, I can run my Flask app, and you'll see it's running on my local host port 5000. I can go back here and we'll refresh this so you see that it's working. So this is the web app. I've named it Blaise Stats, and you can see we're going to look at players' EGS and LGS metrics. So how it works is you go to the Calculate Stats page and you just type in a player's name, Mike Trout, for example. After pressing search, you can see it generates this visualization of what his late game slugging percentage is, his early game slugging percentages, and his normal slugging percentages, which should be weighted more towards the EGS side of things just because more at-bats occur in the early game just because of the number of innings played. So you can do this for a number of players. You can just start typing in random people and checking out their stats. So this guy didn't have any at bats, kind of bad choice, but like Jason, Worth, I can check him out. You see that he actually batted better in late game scenarios compared to early game scenarios, as opposed to Mike Trout, who had a better batting productivity in the early game compared to late game. There's also an about page that kind of walks you through, how this app works and what the statistics are that it generates. I did run into some issues with the MLBAM lookup where even just inputting a player's name did not generate a single MLBAM. So I chose to omit a bunch of the players from the, I guess, look-upable data set on the web app. So if you want to see a full list of players that I did not include, it is these guys. There's about 250 names, which seems like a lot, but a bunch of them were just these ones that names, had been abbreviated and couldn't be dynamically looked up, or people with common names where like Andersons and all those guys had multiple entries in the MLBAM data set. So once I ran my query, I was able to generate this massive data set that has each of the players' names, their SLG, LGS, and SLG gain, which is just the difference between LGS and EGS. With that, I pulled directly from that data set in my web app. This is the actual deployed version. If you want to go to blaisestats.com and just running that, it'll take you to this page here. It works the same as that local version. I just noticed some styling issues where the local version looked a little cleaner, so I thought I'd show you that. But yeah, functionality is the same. You can look up any player you want and it'll actually come up with their EGS and LGS statistics. So if you want to check out my web app and how I deployed it, go to my Sabermetrics GitHub repo here for Blaise Stats and follow the link here to go straight to the web app. And I have a full report here on any information that I thought was relevant to the statistics themselves or the web app. I will note my web app is being deployed on Heroku, so um, it will not, I'll keep it up for as long as possible, but since I had to create a Postgres database instance, it is costing me a little bit of money, so I plan on taking it down, towards the end of May after this assignment gets graded. But if I could find a way around not having a Postgres database, I might consider keeping it up for a while and maybe making some improvements, like, adding more stats than just these ones, and you know, that sort of stuff. So I hope you liked my web app, and feel free to clone the GitHub repo and use it to generate your own statistics. Thank you. Bye.